using the quadratic formula. So I've got a couple of examples here. The first one is determine the number of solutions of the following quadratic equations using the discriminant. So to do this, what I'm going to do is I'm going to work out each part. So A is 1, because there's really imaginary 1 here. B is 5, and C is -3. So the discriminant is the part underneath the quadratic formula, the b squared minus 4ac. And this tells us how many solutions there are. So normally when we've factorised, we've had two solutions mainly. Sometimes if we've had a perfect square, we've only had one solution. And sometimes you've seen we can't get any solution. So if we have a look at b squared minus 4ac, b is 5, so I've got 5 squared minus 4 times 1 times -3. And I get an answer of 37. And we know from our notes that if the discriminant is greater than 0, which this one is, there are two real solutions. So now I'm going to try this with the next one. So I'm going to do the same thing. A equals 2, B equals -3, and C equals 4. So taking my discriminant again, I'm going to get -3 squared minus 4 times 2 times 4. And popping that into my calculator, I get -23. So the discriminant is now less than 0. And because I can't take the square root of a -3, I can therefore say there are no real solutions. So having a look at the last one, A once again is 1, B is 6, and C is 9. If I pop that in, the discriminant equals 6 squared minus 4 times 1 times 9. And if we work that out, we get the discriminant is equal to 0. So we say there is one real solution. Nice and easy. Let's have a look at question 2. Here we're being asked to find the exact solutions. So we should know that using exact means we're not going to be picking up our calculator, and we're told to use the quadratic formula. So once again, I'm going to say A is 1, B is 5, and C equals 3. So I'm going to use my formula. X equals minus B plus or minus the square root of B squared minus 4AC over 2A. So popping those numbers in, it's just a direct substitution. So we've got 5 squared minus 4 times 1 times 3 all over 2A, 2 times 1. So if I work this one out, I get -5 plus or minus. I can use my calculator, and underneath the square root sign is 13 over 2. So you can see I have two solutions. X equals -5 plus the square root of 13 over 2, or X equals -5 minus the square root of 13 over 2. So it might be a good idea to pause the video now and see if you can do part B. So looking at part B, A equals 2, B equals -2, and C equals -1. So be careful with those negatives. So X equals minus -2 plus or minus the square root of -2 squared minus 4 times 2 times 1. Now you can see I can write these without putting time signs in, over 2 times 2. So if we work that out using our calculators, two negatives make a positive, so I've now got +2 plus or minus. The calculator gives me 12 over 4. Now, knowing that we still need a bit of practice with our surds, this becomes 2 plus or minus. Now I need to simplify my surd, so 12 becomes 2√3 over 4. And that almost looks done, but on the top I can factorise a 2 out. So I get 1 plus or minus √3 over 4. Now I know I'm not going to be killing any kittens. So 2 goes into 4 twice. So I get 1 plus or minus √3 over 2. So for this one, I have two solutions. I have x equals positive 1 plus root 3 over 2, or x equals 1 minus root 3 over 2. And I'm not writing that down because I don't have enough space, but you do. Anyway, I hope this helps. Have any questions, just ask me in class. Bye.